This video lesson is for Chapter 3, Part 2, Thermal Energy. When I see the word thermal, I think right away of something hot, something warm. So does that mean if I go outside on a cold winter day where it's minus 20 degrees Celsius, does that mean that there is no thermal energy outside? Well, that's a question we're going to try to answer today. But for now, the definition for thermal energy is that thermal energy is the energy determined by the number of particles and their temperature. So if we want to determine the thermal energy present in a certain system, we can look at the number of particles making that system and the temperature of that system. Now, if we vary those factors, first of all, if we vary the number of particles, what's going to happen to my thermal energy? Let's say if I increase the number of particles in my glass of water, so let's say if I add water, well, the thermal energy is also going to increase just because we have more particles. While if we decrease the number of particles, that means if I have less water in my glass, there is less thermal energy present. Now for temperature, if I increase the temperature of my water in my glass, I am also increasing the thermal energy present in my glass of water, while if I decrease temperature, I also decrease the amount of thermal energy. Thermal energy can travel between objects, living things, or any substance. So we might wonder, which way does it travel? Is it from hot to cold or from cold to hot? Basically, if you think about a glass of water, where you're going to drop in an ice cube. So does the ice cube cool down the water, or does the water warm up the ice cube? Which way around is it? Now, let's look at the first example. If we have a glass of water at 60 versus a glass of water at 20, and we bring them super close, so close that they start exchanging their thermal energy, which way is it going to go? Well, from the highest energy to the lowest. In that case, from highest temperature to the lowest. So it's the hot that warms up the cold, not the other way around. If we look at a case where both substances are below water's freezing point, below zero, the same thing is still true. Which one is warmer? Which one has more energy? It's at minus 10. Minus 75 degrees Celsius is extremely colder than negative 10. So it's going to go that way, from negative 10 to negative 75 degrees Celsius. So how is thermal energy transferred? Always from highest to lowest temperature. Or we can say from more agitated particles to less agitated particles. To understand thermal energy, we need to study temperature, which is a measure of the degree of agitation of the particles of a substance. So when you dig a thermometer in any substance, you're actually checking how much the particles of that substance are moving, how much they're shaking and vibrating in that liquid. And we invented different scales for temperature. For example, the degree Celsius, that's the symbol for it, is very practical because we use water as a foundation where water freezes at 0, it boils at 100, and negative 273, well, I'm going to keep that number for later. We have the Fahrenheit degree F, where the boiling point is 212 Fahrenheit. The freezing point of water is 232 Fahrenheit. And that other number here is negative 460. I'll explain that one later. And finally, the Kelvin. Capital K is the symbol for it. The boiling point in Kelvin is 373.15. Freezing point is at 273.15 Kelvin, and that's the most important value, 0, which is called the absolute zero. We think that at that temperature, there is no more energy present in particles. That means there are no more vibrating molecules or atoms, no more shaking, no more spinning. There is no more thermal energy present at 0. So in theory, and we've never been able to reach exactly that temperature in the lab, but you could bring a thermometer down to negative 273 degrees Celsius, which is 0 Kelvin. And by the way, if you want to transform Celsius into Fahrenheit, you got to take your Fahrenheit. Well, excuse me. If you know your Fahrenheit and you want to turn it to Celsius, you take your Fahrenheit minus 32, put that in brackets, times 5/9. If you know your Celsius and want to turn it to Fahrenheit, you got to do 9/5 times your degrees Celsius and add 32 to that. And your degree Kelvin, you take your degrees Celsius and you always add 273 to get your Kelvin. Now, heat and temperature are often used in the same situations in everyday life, but they don't mean the same thing. So heat is a transfer of thermal energy from an object of higher temperature or higher energy to an object of lower temperature or lower energy. And heat can be expressed like this. We can write Q, so Q is heat, and the unit is the joule, capital J. And so we say that heat is equal to triangle, so that's delta, we call that delta, and delta stands for a variation. Delta ET, where ET is thermal energy, and here energy has the same unit again in joules. So that means heat is a variation of energy. Heat is a transfer of energy. So let's make that difference between heat and temperature. Now, temperature depends on the one thing, how agitated the particles are in whatever you are measuring, so that's how much they move. But heat depends on two things. One, the same agitation of particles, just like in temperature, but also it depends on the number of particles present in that substance. So imagine if you have 2 glasses of water containing really hot water. They're at the same temperature. Let's say 90 degrees Celsius water. One glass is really large. You have 1 liter, while the other glass is smaller. Let's say half a liter. Are they at the same temperature? Yes, they're both at 90, and my thermometers are reading the same number because all particles are agitated the same way. But do they contain the same amount of heat? Not at all, because heat depends on the number of particles as well. So the one with a volume of 1 liter has more particles than the one with a volume of half a liter, so it could provide more energy. It contains more energy than the smaller one. Quick question. Can we still talk about heat if we're below 0 degrees Celsius? Well, yes, absolutely. Particles still move, and there is still energy being exchanged even if you are at below 150 degrees Celsius. Of course, the limit is absolute zero with minus 273 degrees Celsius. So we can say that equal quantities of heat can bring about different temperature changes in different substances. For example, if you put oil on your hot plate in the lab, and on the same hot plate you put the same amount of water as what you have in oil, well, you're going to see that providing them the same energy, so you give them the same heat, because they're on the same hot plate, their temperatures will not vary the same way. They will not go up at the same rate because they are different substances. So that's what we mean by heat does not always bring the same changes. Quick question. To heat the water in a child's pool, is it better to add a bucket of warm water at 60 degrees Celsius or a cup of boiling water? Well, even if the cup of boiling water is warmer and the temperature is warmer, it contains less energy than a bucket of warm water at 60. So it's better to use the larger container in that case.